Great, nice to be here.
Pleasure to meet you, my friend. We're in Black Hat in Las Vegas.
Yes.
Black Hat USA 2026. I have to say, I'm surprised the number of people talking about post-quantum computing and cryptography.
Yes.
Overwhelming.
Yeah,
All over the place.
It's because it's no longer theoretical, right?
Yeah.
I mean, it started way back in the 1990s where a scientist named Peter Shor took a look at cryptography and said, well, the RSA algorithms work great, and in fact, they still work great today.
Right.
If I start to hypothesize a different kind of computing technology that turned out to be quantum computing, the attributes of quantum computing and the ability to represent many states at the same time, providing incredible parallelism, all of a sudden those RSA algorithms look very vulnerable.
Right.
Now you say, well, okay, that's 1994, right? We're 30 years, 32 years later, why now? Well, it's taken a long time for quantum computing, and particularly what's called cryptographically relevant quantum computing, to be on the horizon. And what was 5 years ago, a 10 to 15 year phenomenon, you roll forward 5 years, and now it could be as soon as 3 years.
Wow.
Right?
Yeah. It's right around the corner.
It can be.
Before we know it.
It can be. That's why organizations, it's very top of mind for organizations now. And the way we counsel our customers is, this is a journey.
Right.
And there are a number of steps you need to go through, but you need to start today.
Okay.
Right?
We're going to get into those steps. I want to, when people probably hear of quantum computing, mind-blowing,
right.
If you try to figure it out, at least for me anyway. You throw cryptography in there, which is another subject that can be difficult to understand.
You're
right?
absolutely right.
And you mix those together and it's like, I'll deal with that later, because it's too much going on. So maybe in layman's terms, kind of what that looks like and why it's important to understand it.
Let's start with cryptography. We don't realize how much encryption is part of our daily lives. It's part and parcel of almost everything we do with IT. It's about identity,
right.
It's about data control and protection, it's about financial transactions, things like Bitcoin, all wrapped up in this idea of encryption, which is basically using a code to obscure what the real information is. Right. You can go all the way back to the Middle Ages of the different kinds of codes that were used. And as I said—
and in a way to see it if you need to.
You can reverse it
right.
if you have the key,
exactly.
right?
Which is different than a blockchain in some sense. Right?
Yeah, that's true, but there's still encryption as part of the transaction. And as I said, the basic encryption algorithm that we all use today is called RSA, and it's either 1024, 248, it relies on the combination of two prime numbers and a key, and once you have that, everything flows nicely, and it's extremely difficult to peel that apart computationally. You can't brute force the de-encryption or the decoding of an RSA algorithm with classical computing. I mean, it would take centuries. I mean, it's mind-boggling. HPE makes the most powerful supercomputers in the world, and even those aren't up to cracking RSA code. So that's the encryption side.
Right.
So now the quantum side relies on physics that started with Einstein, quantum mechanics, where matter doesn't operate in classical particle physical ways. It operates as waves, and net, there's something called a qubit.
Right.
And a qubit has a property called superposition. And superposition simply means that there's a wide range of probabilities between 0 and 1 that qubit can hold at any one time. Now this is past my pay grade now, but if you know what you're doing with that, it, like I said, gives you a tremendous amount of parallelism that introduces this idea that you can crack an RSA code.
Right. Shortens the time frame from decades to...
in some cases, hours, weeks and hours. Right?
So, all right, so those two together, and I guess the end result, if and when that happens, is somebody can reverse and see.
That's correct.
Because they create the key.
Right,
unlock.
that's right. Yeah. And it has two implications today. One is, obviously, everyone's encrypting data, they're storing it, you don't want to leak it, right?
Right.
But if you leak it today and there's no quantum computing, no harm, no foul, right? But there's this idea of harvest now, decrypt later,
Right.
where the attacker is just loading up RSA encrypted data, waiting for cryptographically relevant quantum computing to show up,
Yep.
right? So, one of the things we counsel our customers is that you have to focus on the critical information that may be safe today, but if it's leaked or you get hacked, could create a problem in the future.
Yeah. And some might think that data 3 or 5, 4 years from now may not be relevant, but that identity sticks around for quite a while.
If maybe it's too late for me, but I'm sure you wouldn't want your social security number or your medical records in the clear,
No.
right? So that's really the challenge.
Yeah, exactly. So let's go to the journey now of organizations need to start thinking about
Yes.
this and preparing. So what are the 3 steps, and maybe give a little overview of each?
And we really, it's thinking and acting, right? So it's a 3-part journey that we work with our customers on. The first one is being cryptographically aware. Which data is most sensitive? Where is it? Is it protected sufficiently? And just making sure you prioritize your IT investments along the lines of, as I said, protecting that information. Then the next step is cryptographically planning. And that's not just putting a set of paper on the shelf and saying, here's what I'm going to do. It's also looking at, as you refresh your IT infrastructure, it could be your network, your servers, your storage, that you acquire products that are already implementing PQC relevant algorithms. So, it's not just standing pat. And again, vendors like Hewlett-Packard Enterprise, we have introduced a wide range of products that have new types of encryption algorithms that are intended to be resistant to PQC.
Okay. And the 3rd step?
Third step, that's being cryptographically nimble. So you also want infrastructure that can be updated quickly, because there isn't a quantum computer yet available to test all of this. Now, while there's smart people like NIST and other government agencies and a lot of cryptologists who study this problem have recommended new algorithms, until we actually get a cryptographically relevant quantum computer, we're not really going to be able to know if it works or not. So you want to be able to turn that infrastructure, be very nimble around the algorithms, the firmware, and everything else that underpins your encryption environment.
Because you might have to pick a new system, new firmware, new keys, I don't know.
All of that's in play.
Yeah.
But again, the basic infrastructure, like we have a server family, which uses a custom ASIC to enforce the encryption for the server environment. Because it's our own ASIC, we can move it very quickly. We can make the changes necessary as the movie unfolds, if you will.
Right. So let's dig in a little bit into each step, because somebody listening and watching this might say, what does it mean to be aware?
Right.
What am I not doing today that I need to start thinking about for tomorrow?
A lot of customers are looking to folks like us to really do a very deliberate service around PQC to address the issues I just talked about. So we have experts that will come in, work with the customer, understand their data environment, what their encryption environment looks like, and start to set them up for the next several phases that are coming. So and we're not the only one. There are services out there that will help customers sort through the headaches that you just talked about, right? How do I figure this all out, right? So that's a very specific, tangible thing that people do.
Okay. And in terms of actions, I guess maybe I'll frame it this way: the conversations within the business. Who's leading them? Is it the CISO?
That's a great question.
Business leader? Is it the CEO who has a hand in all this?
So the CISO is certainly front and center,
right?
Because a lot of the craft that makes our head hurt, the CISO and his or her team.
They know cryptography.
Understands that, right?
Maybe not the quantum.
all they need to know is when quantum shows up, they have a problem, right? And they have to prepare for it, right?
Okay.
But they'll probably understand quantum as well.
Okay.
But now it's starting to get higher level in the organization. Certainly CIO is going to start to be aware. And if you're in places like Europe where GDPR is an issue in protecting customer information and private information, that's a board level issue.
Right.
So we're no longer seeing PQC so far on the horizon that people are going, oh, I don't have to worry about it now.
Right.
It's really bubbling up to very high levels in the organization. But I think the CISO is the center of gravity.
Yeah. And do we have a sense, so I'm not asking you to predict, pull out the magic 8-ball. We don't even know when it's going to happen, something that will crack the code, if you will. I'm hoping we have enough time in between now and then to be ready. Do we have a sense of what it takes to get an environment ready for this? Is it all the way down? It's down to the hardware.
Yeah, so it's a great question.
Starting plan your CapEx right now.
But that's where a vendor that's got flexible encryption environments, so you don't have to swap out hardware all the time. You can put new firmware in, things like that. But your question is, how soon is this going to hit? That's a little bit uncertain.
Yeah.
But the trajectory is being influenced by a number of things. First of all, the basic algorithm that was invented in 1994, that's being improved. So just the amount of work that has to get done has come down. There is much more hardware improvement at the quantum level, things called qubits. There's a lot of vendors producing different types of qubits, but it's not just the hardware, and that's where our supercomputing technology comes in. Qubits are going to be an accelerator to current classical supercomputing. So that means that the workflows, the compilers, the error correction, the management of work between the classical supercomputing environment and the quantum computer are all contributing to this acceleration, because we're making great strides in all of those areas. So this is like Moore's Law on steroids, right? It's not just the hardware, it's everything that's contributing to reducing this window.
Right. As we wrap up, I was joking a little bit, but with some serious, it is top of mind.
Yes.
For a lot of people.
Yeah.
But not a lot of messaging here at Black Hat around this topic. And I want to know your thoughts on why that is.
I'm surprised.
Because all these companies,
I know.
Guess what? They have encryption in their products.
Yeah. So I walked a bit of the floor. I didn't see everything, but I saw one reference to quantum. I'm surprised. And I think perhaps customers are looking to suppliers and partners like Hewlett-Packard Enterprise that do the hardware, the servers, the storage, the networking, the fundamental IT infrastructure as the source of PQC readiness, as opposed to adding it into the environment. It's a different phenomenon. It gets much lower than a bolt-on security product.
So it's more the CTO and the CIO, probably. Though the CISO has it on their shoulder.
Well, we're having a lot more conversations now with the CISO about what our infrastructure is from a security standpoint. We partner with the rest of the security ecosystem, but today, you need that secure foundation, not just for PQC, but in general.
Yeah. So let's close with a bit of advice for the CISO then.
Right.
How they can, if they haven't already started having that conversation, how do they have that conversation, and with whom, and what are some of the key points they need to pull from their own environment and own programs to educate the folks that need to make the final call on this stuff?
So I don't think there's a huge education process here. I mean, it's reasonably well understood. You don't have to be a cryptologist to understand what the challenges are.
Right.
But for the CISO, I think it's broadening the conversation to the IT infrastructure, the infrastructure and operations groups. How are you buying new servers? How are you buying new storage? What attributes are you looking for in terms of encryption and PQC readiness? So it's that collaboration that I think the CISO needs to start having with the rest of the IT organization.
Right. And of course, CISOs own the identity for a lot of this stuff too.
That's exactly right. So that's a point of protection, right? That may be a priority for the CISO to say, okay, if I'm vulnerable, how do I protect it? What's my priority?
All right. So good to chat with you.
It's a pleasure.
Appreciate your time.
Thank you very much.
Fascinating topic.
It is.
And can be a little nerve-wracking perhaps, but sounds like you guys have a nice 3-step plan, starting with awareness.
Yes.
And yeah, hopefully folks connect with you, Larry.
All right.
And,
yeah, we'd love to
HPE
chat with them. And yeah, we're a global company, and we have a lot of resources to offer here.
Yeah, appreciate it.
All right, thanks, Sean.
So connect with Larry and the HPE team, and stay tuned for more coming here from Black Hat, ITSP Magazine.